Good evening friends, we are going to start with another topic today. It is KCL, Gustav Kirchhoff's current law. We know that this is also called as nodal analysis. In nodal analysis we deal with KCL. We know that if we have a network which is like this, and say these are the currents which are coming and these are currents which are leaving. Fine. So we have started it so well until now that this is say I1, this is I2, this is I3, I4, I5. So we know incoming current is equal to outgoing current. Fine. Incoming current is I1 plus I2. It is equal to outgoing current. It is equal to I3 plus I4 plus I5. So I can say that sigma II it is equal to 0. Fine, algebraic sum of all the currents meeting at node, it is always equal to 0. Is it clear? Fine. Okay. So we know, we already knew all these things. So what new we are going to learn in this particular semester? We have studied it into elements of electrical engineering, what is KCL. We have studied it to basic electronics, which was coming in second semester. What difference do we have into this semester? So very first thing we'll analyze one network, which is a very easy network. We have seen into KVL as well. So this is a basic network that we have. Okay, we have started it in KVL. This is R, this is V1 voltage, this is V2 voltage, and I'm interested to calculate the current which is flowing in this loop. I'll write down my KVL starting from C. This is negative, this is positive. Current is flowing like this. For U2, current always flows from high potential to low potential. So my assumed direction of current is like this. Fine. For my assumed direction, fine, I can say that the current flowing in this resistor, it's like this. So I can say that if current is flowing this way, it has to be higher potential, it has to be low potential. If the current is flowing this way, I say that this is higher potential, this is low potential. Is it clear? Fine. Okay. And this is obviously, this is plus and minus. Now I write down my KVL equation over here. Now I write down my KVL equation over here, and it is like V1, it's plus V1 minus I into R, that's the voltage drop across the resistor, and minus V2, which is equal to 0. Now, let's say I have to formulate I now. So I'll say that IR, it is equal to, I have taken IR over here. So it is equal to V1 minus V2, and therefore I, it is equal to V1 minus V2 divided by R. So I have got the first formula for current. This I am going to use a lot. Now, so but this you already knew. We have done it into KVL. Why you are teaching it right now? The reason is that now I am going to modify this particular network. Fine. I'll write it this way. I have one node. I have a resistor connected to that node, and then I have another node. At this node, with respect to ground, I have plus V1 volt. And with respect to ground, I have plus V2 volt at this particular node. So this is plus V2. Is it clear or not? Fine. And now I say, see, voltage is always a difference. There is no absolute voltage. Voltage is always in between two terminals. Is it clear? Fine. So when I say it's V1 volt over here, so it is always with respect to ground. Is it clear? Fine. And now I consider, say the current is flowing like this, and which is I. You know the formula of current. Current always flows from higher potential to low potential. So obviously it's V1 minus V2. That's the potential difference divided by R. So that is the formula of current. Is it clear? So this is the way we have got a very basic equation of KCL. अब तक वो पता नहीं चलता था कैसे वो equation आया. We have understood the very basic of how that equation is coming. Is it clear to all of you? Now let's deal with a very small tiny little network. So we have such network, which is a very small network. I am interested to calculate branch currents. I am interested to calculate branch currents into this. This is say 10 ohms, 10 ohms, 10 ohms, 10 volts, 20 volts. Okay, fine. So I can definitely say here we have plus 10 volt. Here at this node we have plus 20 volt. Yes or no? Fine. Is it clear? Okay. And here also we have got one node where I don't know what is the amount of voltage. So this is the node where I consider the voltage is V. Where I consider some unknown voltage is V. Now the way in KVL, we were finding the loop currents, or we were assuming the loop currents. Here what we will assume first of all how many of the number of nodes we have. Actually we have only one node. Fine. But at this point, what is the voltage? So with respect to ground, we have plus 10 volts over here because this plus is connected. Fine. With respect to ground, plus 20 volts is over here because plus is connected here. Is it clear? And now we have one node over here. Fine. Now for KCL, what will we do? We'll say that all the currents meeting at node is the addition of all the currents meeting at node is equal to 0. You can take any direction of the current, say like this. All are incoming, and incoming. So let's give some names to them. I have this as I1, I have this as I2, I have this as I3. Is it clear? Fine. Okay. So we'll say that all currents coming together, addition becomes 0. The addition becomes 0. So I'll be having I1 plus I2 plus I3 is equal to 0. Is it clear? Now let's say I1. What is I1? I1 is the current which is flowing in this branch. So now you forget rest of the network. Remember, one voltage source, another voltage source, resistor, current. So I can say that the current flowing in this particular branch is given by this voltage minus this voltage upon R. So this voltage is plus 10, this voltage is plus 10, this voltage is unknown voltage minus V, but I'll take negative. Why? We have to take the difference over here. Find higher potential minus lower potential divided by resistance divided by 10. Plus, when we talk about I2 is coming like this. Again, let's consider such network. Plus 20, then this is 10, and this is V. Current is flowing like this. Current always flows from higher potential to low potential. So I can say it's 20 minus V divided by 10. Is it clear? Any doubt on this? So we have got second current which is 20 minus V divided by 10. So 20 minus V divided by 10 plus I3. I3 also we have such network. See, this is V and this is ground. And this is how we have a branch. This is 10 ohms. Current is flowing this way. So this has to be higher potential. This has to be low potential. High. This is ground. Matlab this is 0 volt. This is V volts. So I can say 0 minus V upon 10. Is it clear? So I can say that this is 0 minus V divided by 10. It is equal to 0. So one equation, one unknown. I can calculate unknown. So 10 by 10, 1 minus 0.1 V plus. This is 2 minus 0.1 V plus. It's minus only, minus 0.1 V, which is equal to 0. So I can say that 1 plus 2, that is equal to 3. 0.1 plus 0.1 plus 0.1, I mean 0.1 minus 0.1 minus 0.1 minus 0.1. It is equal to minus 0.3. It will go that side, become positive 0.3 V. And hence we can say that V, it is equal to 3 divided by 0.3, which is equal to 10 volts. So therefore, we have got V, which is equal to 10 volts. And when I put this value of U here, and here, I can easily calculate all three currents. That you can definitely do. Is it clear? Any doubt on this? Fine. Now let's deal with another network in which we have something like this. So this is 10, 20, 30, 10, 10, 2. Is it clear? Fine. So how many nodes we can see? 2 nodes are there. main two nodes are there, node number 1, node number 2, and there is another node which is called as grounding node or datum node. Is it clear? Fine. Where potential is always equal to 0 volt and rest of all the potentials are taken from with respect to this particular point. Is it clear? Fine. Okay. Now let's see. I'll consider this is V1, this is V2. Okay. So the way in KVL we have number of loops, here we have number of nodes. Fine. So we got two nodes over here. Fine. So now let's say we will be taking current. So one current is coming, other is also coming, third one is also coming, right? And in this case, one is coming, other is coming, third is coming. Is it compulsory to take it this way? No. You can take it at your will. Fine. If you wish, one is coming, second is coming, third is going. That's okay. That's okay. Fine. Then all the equations will be changed that way. Fine. But answer will not be affected. Got it? Fine. Sure. So let's say in first loop, so blue one. So I'll say that this is I1, this is I2, this is I3. So I can say that I1 plus I2 plus I3. This is at V1 node. Fine, it is equal to 0. So I1 is what? It is 2 amperes plus. I2 is what? 0 minus V1 upon 10. Got it? Because this is higher potential, this is low potential. Why? Because current is assumed in this direction. Current always flows from higher potential to low potential. So we can say that this has to be higher potential, it has to be low potential. So this is 0 minus V1 divided by 10. Do you both are understanding it or not? Fine. Okay, it's very simple. Plus, then when we talk about this third current, it's V2 minus V1 upon 20. Current is flowing this way. Blue current is flowing this way. So it's V2 minus V1 upon 20. Clear? You can simply compare this with this. V2, V1, R. Current is like this. So V2 minus V1 upon R. We have derived that as well. How it is coming? Clear? So now let's say it's V2 minus V1 divided by 20, which is equal to 0. We can solve it and we will get an equation. Let's write down 2 minus 0.1 V1 plus it's 0.05 V2 minus 0.05 V1 is equal to 0. Fine. Okay. It's 1 by 20 is 0.05. So we have got 0.1 and this is 0.05. So it's minus, we can say 2 minus 0.15 V1 plus 0.05 V2 is equal to 0. So I can say that we will take it that side. So it's 0.15 V1 minus 0.05 V2 is equal to 2. So I have got my first equation of V1 and V2. Is that clear? Fine. Now let's say we'll apply things to node 2. So now I'll write down it is red. So at V2, I'll again say that. Say this is I1, this is I2, and this is I3. So I'll say that again. I1 plus I2 plus I3 is equal to 0. I guess it is not working properly. So I'll go for again black one. So I1 is what? It's V1 minus V2 upon 20. Fine. So I can say that it's V1 minus V2 upon 20 plus I2. What is the value of I2? 0 minus V2 divided by 30. 0 minus V2 divided by 30. I hope it is clear. And let's deal with the third one. That's okay. Here, how much amount of voltage do we have? It's plus 10 volts. Is it clear? Fine. So we have got 10 minus V2 divided by 10. 10 minus V2 divided by 10, which is equal to 0. We have just now mixed all the colors. So let's say this is 0.05 V1 minus 0.05 V2 minus that comes out to be a bit difficult. 0.033 V2 plus 1 minus 0.1 V2 is equal to 0. So we can say that V1 is 1 only. So 0.05 V1 0.5678. Fine. So it's minus 0.183 V2 plus 1, which is equal to 0. So I'll take that one that side. So I'll be having 0.05 V1 minus 0.183 V2 is equal to minus 1. So I've got another equation. Two equations, 2 and 1. You can solve it. Do you understand? Isn't it simple? Right? Any doubt on this? Okay, done. So this is a very basic understanding of KCL or nodal analysis. Fine? Okay? Done. Right.